Number one, select all the equations on which point 10, 0 lies. I need to remind you guys that 10, 0 is, by the way, in parentheses, the first number is an x number and the second number is a y number. Because of that, as I look at these equations, everywhere there is an x, I can put 10. Everywhere there is a y, I can put 0. So when it says, if this point lies on the line, if it does that, it needs to satisfy the equation. It needs to make the equation work. If these numbers, x and y, do not make the equation work, then it's no, it does not lie on that line, okay? So for A, I'm going to do 5 times 10, and I write it as parentheses because I'm filling in or substituting that 10 into the x position, plus 2 times 0, there's my y, equals 15. I'm following this, okay? For the x, there's now a 10. For the y, there's now a 0. 5 times 10 equals 50. 2 times 0 equals 0. And that would equal 50, not 15. So A does not have that point on it, okay? Now I need to keep going here. Here's B, 2 times x, which is 10, plus 4 times y, which is 0, equals 20, okay? 2 times 10 is 20. 4 times 0 is 0. 20 plus 0 equals 20. That's a yes. B is correct. Or B is a equation that point would be on it. Okay? For C, x is 10 plus 6 times y, which is 0, equals 10. 10 plus 6 times 0 is 0, equals 10. That's a yes. C would have that point on it. D, 3 times x, which is 10, plus 3 times y, which is 0, equals 13. 3 times 10 is 30. 3 times 0 is 0, which would equal 30. So that is not true. D does not work. For E, 4 times x, which is 10, plus 2 times y, which is 0, equals 20. Well, 4 times 10 is 40. 2 times 0 is 0. That equals 40. That's a no. Okay? For F, okay, I have 6 times 10, or 6 times x, which is 10, plus y, which is 0, equals 50. Well, 6 times 10 is 60, plus 0 equals 60. So that is also a no. Okay? 2. A successful music app tracked the number of song downloads each day for a month for 4 music artists, represented by lines L, J, M, and D. Which line represents an artist whose downloads remain constant over the month? Okay? So I have to focus on something here. It says the number of song downloads each day. Okay? So I have to imagine, these are individual days. So if I use line J, for example, a little off your camera, sorry. If I use line J, for example, on day 1, it downloaded, let's say that's 2 songs. On day 2, it downloaded 4 songs. Okay? It's downloading more songs every day. Okay? So kind of thinking of the scenario, this is not 2 songs a day. This is 2 on that day, 4 songs downloaded that day, 6 songs downloaded that day. So J is not a good example. Okay. Now I have to also assume then any line that is going up or down is not a good example. D is not consistently the same amount each day. Whereas if I go across M, let's say that's, 3 songs, just to make it up. On day 1 is 3, on day 2 is 3 more songs, on day 3 is 3 more songs, on day 4 is 4 more songs. So every day 4 songs are downloaded for M, remaining constant over the entire month. So line M would be correct. Number 3. Okay, it's all these different graphs. A pool holds 19,900 gallons of water. There are 2 hoses that can be used to fill the pool, a large one and a small one. On an average day, it takes 5 hours to fill the pool with the large hose, and it takes 12 hours to fill the pool with the small hose. Which graph best represents the scenario? Okay, so just for some sketching and jotting down some information, the small hose is slower, which makes sense, and the big hose is faster, which makes sense. Okay, so I have to be looking at some paces or speeds on here. I'm looking for some what would represent faster or slower. So I'm going to zoom in a little bit here. Okay, looking at graph A. Okay, I have time, and as time goes more, I have water of gallons used. Okay, so right now the small hose is showing me less gallons over time, and this is where if I want to act like there's a time in hours here, I want to see obviously that the large hose is showing me more water at the same amount of time, and the small hose should be less water at the same amount of time. So I believe graph A seems to be fitting this scenario, but I'm going to check some of the other graphs and see why, or if they're fitting. Maybe I'm making a mistake. So time over hours, again, that's on X, so I'm going to draw a line straight across that. And this is showing me that at that point the large hose is less water and the small hose is more water. So I don't like that scenario. I don't think that's working out. Okay, so the last 2 have switched the labels. So time is now becoming more as I go up, and water used is to the right. So I need to pick a spot on time. Needed to align with both lines. So let's say that that's 2 hours, and again, more water now means right. Okay, so whatever line is going further right means more water. So in this case, the large hose at whatever time period that is less water. The small hose is more water, so that's not a good scenario. The large hose should have more water. Okay, what do these straight lines mean? This is time again. Okay, and if it is a line going straight up and down in time, I don't know if or how that's possible, because this point would mean, for example, like 1, 2 hours, 3 hours, 4 hours. That somehow at exactly 2 hours, this pool goes boom, full of water. And at 4 hours, this pool goes boom, just instantly full of water. Don't know how that's possible, so I don't like that graph. Doesn't work out. So graph A is the correct graph here.